But if you want to, do them. What's more important, high protein or caloric surplus for bodybuilding? High protein, 100%. If you are in a caloric surplus and you're not getting adequate protein, you won't build shit for muscle. You need to remember, your body builds muscle from the amino acids in dietary protein. So you got your muscle cell, you got your nucleus. So this is basically what happens. You stimulate an anabolic pathway, like mTOR. A bunch of stuff goes on, tells the nucleus to tell the ribosomes, I forget how they draw them, to use amino acids so you stress your muscle, turns on mTOR, or whatever anabolic pathway. The mTOR pathway does a bunch of nonsense, tells the nucleus that we need to build more tissue. The nucleus sends the signal to the ribosomes in the cell to use the amino acids to build more contractile proteins, actin and myosin. So then your muscle cell grows the amount of actin and myosin that was terrible. So then your muscle cells, so this is what happens. Pay attention. Metabolic stress, mechanical tension, stimulates anabolic pathways, such as the mammalian target of rapamycin, or mTOR. mTOR sends a signal to the nucleus in your muscle cell, or the nuclei of your muscle cell, because there are more than one, which tell the ribosomes to use amino acids that you get through dietary protein to build more actin and myosin contractile tissues. So what happens is, here's your starting muscle cell. 1, 2, 3, 4, 5, 6, 7, 8, 9 myofibrils that have the actin and myosin inside of them. So these are myofibrils. So you got muscle cell, myofibril, actin, myosin, contractile proteins. So this happens, and it tells this to add more contractile proteins. So each myofibril gets larger by adding more contractile proteins, which makes the whole muscle cell grow thicker. It's like blowing up a balloon with more air. That's why muscle grows. Muscle growth is a side effect of improvement in the myofibrillar pool, meaning additional or bigger myofibrils. A bigger myofibril with more contractile proteins in them can produce more contractile force. So the goal is to tell the muscle to get stronger by adding contractile proteins in the myofibril. As a side effect of adding more contractile proteins, the myofibrils have to expand to accommodate additional contractile proteins. Therefore, the entire muscle cell has to grow and expand to accommodate more contractile proteins in the bigger myofibrils. That's why you cannot train for just muscle growth. You have to train for improvements in muscle strength, because the growth process, the expansion of the myofibril, is a side effect of improving muscular strength. But as you can tell, this happens really slow. It happens slow because your ribosomes are taking amino acids through dietary protein and building tissue, contractile proteins, out of nothing, out of thin air. At It's a slow process. It requires energy. It requires energy to do all this. So this is why protein is important, because if you don't have amino acids, how are your ribosomes going to build new contractile protein? What are they going to build them out of? It's like showing up to a building site with a blueprint and no wood, no bricks, no building material. Your ribosomes will just sit there like a bunch of laborers with nothing to do. Sure, so say you have energy. Say you have energy, but no amino acids. So you've got the ribosomes, which is the blueprint. You've got the energy, which are the workers. You got no building materials. So there's no point in eating a bunch of calories and having a lot of energy when there's nothing for the energy to help the ribosomes do, which is use the amino acids and build contractile tissues with them. So yeah, you need high protein.